Hello, bedtime thinkers, and welcome. This is the Bedtime Discoveries, where we gently explore the mysteries of science and drift toward a peaceful night's rest. Tonight, we'll take a quiet journey into a question that feels both fascinating and mysterious. Are we living in a simulation? The thought may sound like science fiction, but some of the greatest minds in philosophy, computer science, and physics have taken this possibility very seriously. Could our universe, with its rules, its patterns, its beauty and strangeness, be part of something far larger, a carefully constructed simulation? Before we begin this gentle exploration, I invite you to share something in the comments. Tell me softly where you are listening from and what time it is for you right now. It's always calming to see how connected we are across the world, each of us drifting into night at our own pace. And if you find comfort in these bedtime discoveries, please consider giving this video a gentle like and softly pressing subscribe so you can join me on many more calm journeys into the quiet wonders of science. Close your eyes for a moment and imagine the world around you. The warmth of your blanket, the rhythm of your breath, the gentle beating of your heart. All of it feels real, solid, certain. But what if beneath this comforting surface reality itself is not what it seems? This is the essence of the simulation hypothesis. It is a suggestion that everything you see, everything you hear, everything you experience could be part of a vast, carefully constructed simulation, not just a game, not just a dream, but an entire universe running on rules, on patterns, on hidden code. When people hear this idea for the first time, many smile or shake their heads, thinking it must be fantasy. But the deeper you sit with it, the stranger and the more possible it begins to feel. After all, what does it mean for something to be real? Is a rainbow real, though it is only light and water droplets? Is a dream real, even if it fades away upon waking? And what about a thought or a memory, things we cannot touch but still experience fully? The simulation hypothesis asks us to step into that same kind of uncertainty, to imagine that our world is perhaps only one layer of something larger, like pages in a book or characters in a play. We live our story without knowing the author who wrote it or the stage upon which it is set. What makes this thought so powerful is that it connects both science and philosophy. It is not only a playful speculation, but a question that some of the most brilliant minds have considered carefully. Could we, with all our intelligence, our history, our technology, be unaware that we are part of something else? And if so, what does that mean for who we are? For centuries, humans have wondered about the nature of reality. From ancient myths to philosophical debates to modern science fiction, the same question quietly reappears. Is the world we see the whole story? Or is it only a surface hiding deeper truths beneath? The simulation hypothesis gives that old question a modern form. Instead of imagining gods or spirits weaving illusions, it suggests advanced civilizations with unimaginable technology, building worlds so detailed, so convincing, that the beings within them never suspect. And if we are those beings, then everything around us, the stars, the earth, even ourselves, might exist only as data, flowing in a system too vast for us to see. It is not an easy idea to grasp. But for tonight, let us not wrestle with it like a puzzle to be solved. Instead, let us hold it gently, like a small light in the dark, and let its strangeness slowly soothe us as we drift deeper into thought and deeper into rest. When you look closely at the world, you may notice how ordered it feels. The sun rises each day, the seasons cycle, gravity always pulls us down, Fire always warms and water always cools. There's a comfort in this regularity, a sense that the universe follows certain laws. Now imagine that these laws are not simply natural. Instead, they might be the rules of a simulation, like the physics in a video game, where objects always fall downward, where light always moves in straight lines, where cause and effect always connect. Our universe, too, may be running on a set of hidden instructions. The simulation hypothesis suggests that these instructions could be like code, a language written into the very structure of reality. When we study the universe through science, we are not only discovering nature, we may also be glimpsing the rules of the program. And the more we learn, the stranger these rules sometimes appear. For example, time itself seems flexible at the quantum level. Particles behave unpredictably, as though flickering between possibilities, until they are observed. Space is not smooth, but may be woven from tiny units, like pixels on a screen. And energy seems to come in discrete amounts, as though reality has the smallest bit of information. These observations have led some scientists to wonder, could reality itself be digital at its core? Not flowing endlessly, but built from tiny building blocks, the way a simulation would be. Of course, this is not proof. The universe may simply be stranger than we can imagine, but the resemblance, the echo of programming, is hard to ignore. Consider this. When we create computer simulations, we choose efficiency. We render only what the player sees. A distant forest in a game may not exist in detail until you walk toward it. In the same way, the universe appears to collapse into certainty only when it is observed. Could it be that observation itself is like the system loading in the details? It is a delicate thought, like balancing a feather on the palm of your hand. But it reminds us that reality may not be as solid as it seems. Instead, it may be a shifting, fluid tapestry, held together by rules we are only beginning to glimpse. And as you drift further into this idea, let it soften you. Let the rules of the world feel less rigid, less heavy, because whether the laws of physics are natural or programmed, they still hold us gently in place, allowing us to dream within them. What does it mean for us to live inside such a possibility? If the simulation hypothesis is true, then our lives are not less real. They are simply real in a different way. Just as a dream can be meaningful, just as a story can move us to tears, our reality, too, holds depth and wonder, even if it is not the base reality. Imagine a character in a novel. To that character, their world is the only world. They walk through streets, speak to others, feel love and loss, all within the pages of the book. And though the character may not know the author or see the paper upon which they are written, their experiences are no less true to them. In the same way, if we live in a simulation, our lives remain rich and full. The laughter of a child, the beauty of a sunset, the touch of a loved one's hand, these are real to us, as real as anything can be. A simulation does not erase meaning. It simply changes the framework within which meaning arises. Some thinkers even suggest that a simulated universe could have purpose. Perhaps it was created to preserve knowledge, to run experiments, to give rise to consciousness again and again. Perhaps it was made out of curiosity or even compassion. If so, then our existence is not random at all, but part of a design. Of course, we cannot know for sure, and perhaps we never will. But in the gentle quiet of night, this mystery becomes less of a problem to solve and more of a lullaby to rest within. Because whether our universe is the first or the billionth, whether it is natural or simulated, we are here. We are alive. We are dreaming and wondering and feeling, and that is beautiful. So tonight, let the simulation hypothesis not trouble you, but soothe you. Let it remind you that reality is vast, layered, and mysterious, and that within it, you have your own place, your own story, your own soft corner of existence. And as a thought drifts with you into sleep, remember that reality, whatever its form, is still holding you gently, cradling you into rest. Long before computers, before virtual reality, before even the idea of science as we know it, people were already asking a very deep question: what is real? The simulation hypothesis may sound modern, tied to circuits and digital code, but its roots are ancient. Philosophers, mystics, and poets, for thousands of years, have whispered of a world that is not quite what it seems, a world of appearances, a stage, a veil. One of the most famous stories comes from Plato nearly 2,500 years ago. He described the allegory of the cave. Imagine, he said, a group of prisoners chained in a cave since birth. They cannot move, they cannot turn, they can only face one wall. Behind them burns a fire, and between the fire and the prisoners, other people walk, carrying objects that cast shadows on the wall. The prisoners see only the shadows. For them, the shadows are reality. The shapes, the movements, the flickering forms, these are the world as they know it. But one prisoner breaks free and turns around. For the first time, he sees the fire and the people walking with objects. He realizes the shadows were not the full truth, only a projection of something deeper. If he continues upward, out of the cave, he will see the sun, the open sky, the real world beyond. And yet, if he returns to the cave and tells the others, they may not believe him. To them, the shadows are all that is real. This ancient tale feels uncannily like an early version of the simulation hypothesis. It suggests that what we see may only be shadows, illusions cast upon the walls of our perception. And just as the prisoner mistook shadows for reality, we, too, might be mistaking the simulation for the ultimate truth. Think about how this connects to our lives. We trust what we see with our eyes, what we touch with our hands. But our senses are only channels, limited and narrow. We do not see the full spectrum of light. We do not hear the full range of sound. We perceive only a thin slice of what is. Could it be that our senses are the cave walls, and reality beyond them is hidden, waiting, far larger than we can imagine? Plato's story whispers across centuries, a reminder that humans, even in ancient times, felt the strange tug of this question: is the world as it seems? Or are we living in shadows? As you think about this softly tonight, let the image of the cave drift into your imagination, dark, echoing, filled with flickering shapes. And imagine yourself gently turning, slowly walking upward, toward light, toward the greater reality that waits just beyond the wall. Another ancient echo comes from the east, from the teachings of India and China. For thousands of years, philosophers and spiritual teachers have described life itself as a kind of dream, a play, an illusion. In Hindu philosophy, there is the concept of Maya. Maya means illusion, not in the sense of simple trick, but in the deeper sense that the world we see is not the ultimate reality. The forms, the colors, the names, the stories, they're like waves upon the ocean. Beautiful, moving, vivid, but not the true depth beneath. Beneath Maya lies Brahman, the ultimate, infinite reality that underlies all things. When we see only the surface, we live inside Maya. When we awaken, we glimpse the deeper truth. Does this not sound like another way of describing the simulation hypothesis? A universe full of patterns, convincing and immersive, but beneath it, something greater, more fundamental? When the ancient sages spoke of Maya, perhaps they were pointing toward the same mystery, using different language. In Chinese philosophy, the Taoist sage Zhuangzi told a famous story. He once dreamed he was a butterfly fluttering through the air, carefree and light. When he awoke, he asked himself, was he Zhuangzi, who had dreamed of being a butterfly? Or was he a butterfly, now dreaming he was Zhuangzi? Where exactly is the line between dream and waking? And how do we know which one is real? This story feels like a gentle echo of simulation as well. For if we cannot be sure whether a dream is less real than waking, how can we be sure that waking is the final reality and not simply another layer? In Buddhism, too, reality is described as impermanent, shifting, dreamlike. The mind constructs a world from sensations and thoughts, but that world may not be the ultimate truth. Like a mirage or a reflection in water, our experiences are vivid, but not fixed. To awaken in this view is to see through the illusion, to glimpse reality beyond the appearances. All of these traditions, from Maya to Zhuangzi's butterfly to the Buddha's view of impermanence, carry the same gentle suggestion. Our world may not be the whole story. What we call real may itself be a layer, a dream, a simulation. And though these teachings were not written with computers in mind, they resonate beautifully with the modern idea of simulated worlds. For whether we call it Maya, or illusion, or simulation, the question remains the same. How can we be certain that what we see is the deepest reality? As you breathe softly, letting these echoes move through your thoughts, you may feel a gentle calm, knowing that this question has been with humanity for thousands of years. You are not alone in wondering. Generations upon generations have looked at the stars, the rivers, the sky, and whispered, "Is this all there is?" Another ancient image that returns again and again is that of the world as a stage. The Roman philosopher Cicero, the Indian poet Kalidasa, and later William Shakespeare himself all spoke of life as theater, as performance. We are actors, they said, stepping onto the stage for a short time, speaking our lines, playing our roles before the curtain falls, and we leave. The Stoic philosophers of Greece and Rome took this further. They suggested that the roles we play are assigned by fate or by the cosmos itself. Some of us are kings, some servants, some warriors, some lovers. But the role itself does not matter as much as how we play it. To live well is to perform your part with dignity, with honesty, with grace. Now imagine this idea in the light of the simulation hypothesis. What if the stage is not only a metaphor, but literal? What if the roles are written not only by fate, but by the code of the simulation itself? We might be actors in a play designed by beings beyond our comprehension. The scenery, the props, the script, all programmed into the world around us. We live our lives inside the theater, never seeing the audience beyond. This ancient image reminds us of something important. Even if reality is a stage, even if it is an illusion or a simulation, our experiences within it are still meaningful. The laughter, the tears, the struggles, the joys, these are the lines we are given, the performance we embody. And the play is no less beautiful because it is a play. In fact, the awareness that life may be staged can bring a strange kind of freedom. If all of this is illusion, if it is a dream, if it is a simulation, then the heaviness of reality softens. We need not cling too tightly. We can let life flow, knowing it is both fragile and profound, temporary yet luminous. And so the echoes of the ancients reach us gently tonight. From Plato's cave to the dream of the butterfly to the stage of the world, all point to the same quiet mystery, that what we call reality may only be a reflection, a surface, a layer. The simulation hypothesis may use new words, computers, programs, data, but the question itself is as old as human thought. Are we seeing the truth, or only the shadow of something deeper? As you let these echoes settle into your thoughts, feel their calm weight, their timelessness. You are not the first to wonder, and you will not be the last. For as long as humans exist, the question will rise again and again, softly like a whisper in the night. And perhaps that is the beauty of it, not to solve the mystery, but to let it cradle us, to live inside it gently, curiously, peacefully. The ancient echoes we explored still whisper in our minds. But in more recent times, the simulation hypothesis found new life, a modern spark, in the voice of a philosopher named Nick Bostrom. In 2003, Bostrom published a paper with a quiet but powerful argument. It was not written as science fiction, but as philosophy, logic, probability. And it caught the attention of scientists, thinkers, even technologists around the world. Bostrom's thought went like this: imagine that civilizations, if they survive long enough, eventually gain incredible technology. Technology so advanced that it can simulate entire worlds, filled with conscious beings who believe they are real. If that happens, then the number of simulated worlds may far outnumber the one original world. In fact, there could be billions or trillions of simulations. If so, then the odds suggest that we are far more likely to be living in one of those simulations than in the rare original reality. It is a startling idea, but Bostrom laid out gently, step by step. He proposed that one of three things must be true. First, perhaps civilizations never survive long enough to reach such advanced technology. They may destroy themselves or fade away before they can build simulations. Second, perhaps civilizations do reach that point, but choose not to create simulations. Maybe they find it unethical or pointless or simply unnecessary. Or third, civilizations do survive, and they do run simulations. And if they run countless simulations, then the vast majority of beings, like us, would live inside one. When you think about this slowly, it has the shape of inevitability. If even one civilization in the entire universe creates simulations and runs them at scale, then reality will be filled with simulations, layer upon layer. And the odds that we are in the original, base reality become vanishingly small. This was the modern spark, a calm, rational argument placed on the table, inviting the world to consider, what if? Scientists debated. Some dismissed it as speculation. Others, including names as large as Elon Musk, said the odds we are in a simulation may be overwhelming. The discussion spilled out of philosophy journals and into popular culture, news articles, late-night conversations. What makes Bostrom's argument so powerful is its simplicity. It is not based on strange physics or mysterious experiences, but on logic, on the math of probabilities, on the idea that if something can be done and is likely to be done, then it may already be happening, and we may already be part of it. As you let this thought rest in your mind, notice how calm it feels. It does not demand panic or fear. It simply opens a door, a possibility. That reality may not be singular, that our world, with all its detail and beauty, may be one of many, and in that possibility lies a spark. For many people, the idea of living in a simulation feels familiar, even comfortable. That is because long before Bostrom's paper, the idea had already been painted vividly in stories, in novels, in films. Think of The Matrix, the famous movie where humans live inside a simulated world, their bodies asleep, their minds convinced that the dream is reality. When Neo discovers the truth, he awakens into a harsher, deeper world. The film became a cultural landmark, not only because of its action, but because it touched a nerve. It echoed that old question, what is real, and wrapped it in modern technology. Even earlier, writers like Philip K. Dick filled their stories with blurred lines between reality and illusion. He once gave a lecture, calmly insisting that we may indeed live in a computer program. He was not laughing when he said it. He believed it was possible. Science fiction has always been a way for us to test ideas before science itself can. Through imagination, we explore futures, technologies, and mysteries that may later become real. And so the simulation hypothesis, long before it was a formal argument, was already living in the minds of dreamers. When Bostrom's paper appeared, it was as though philosophy had caught up with fiction. What was once a dramatic story became a sober, logical thought experiment, and the world paid attention. Physicists asked, could we test it? Technologists wondered, could we build it? Philosophers debated, does it change the meaning of life? The strange thing is, Bostrom's argument does not require proof to unsettle us. It only requires imagination. Because once you admit the possibility, the idea has a way of lingering quietly at the edges of thought. When you see the stars, you may wonder if they are programmed pixels. When you feel the laws of physics at work, you may wonder if they are lines of code. When you dream, you may wonder if waking is simply another layer of dream. This is the beauty of the modern spark. It turns a playful question into a serious possibility. Not only a story, but a hypothesis, one that cannot easily be dismissed. And as you drift deeper into this thought, let it soften your sense of certainty, not to trouble you, but to free you. For if reality can be layered, if illusions can hide within illusions, then life is a mystery larger than we know. And mysteries at bedtime are a gentle comfort. How do we live if the simulation hypothesis is true? Does it change anything about our day-to-day lives? Some people, upon hearing it, feel a kind of vertigo. They wonder if life is meaningless, if everything is false. But this is not the only way to see it. In fact, many thinkers suggest the opposite. If we are in a simulation, then perhaps we were created deliberately, not by accident, but with intention. Perhaps our world was designed for beauty, for learning, for growth. Perhaps we are part of an experiment, yes, but experiments often seek knowledge, understanding, progress. If so, then our existence has value, simply by being observed, by being lived. Others suggest that meaning is not reduced, but deepened, because whether the stage is natural or programmed, the play is still ours. The emotions we feel are real to us. The sunsets we watch are beautiful to us. The love we share is profound to us. Reality, simulated or not, holds all the richness we experience. And there is another possibility, too, that the simulation hypothesis is not about proving or disproving, but about shifting perspective. It invites us to see the world as more mysterious than we assumed, to loosen the grip of certainty, and to embrace the wonder of existence, no matter its form. For at bedtime, this thought can be soothing. It tells us that the universe may be vast beyond measure, that there may be layers upon layers of reality, each one unfolding into the next. And yet, here we are, in this layer, in this moment, breathing softly alive. When Bostrom lit the modern spark, he was not giving us fear. He was giving us curiosity. He was reminding us that reality is not as obvious, not as simple as it seems. And curiosity, at night, is a gentle flame. It does not burn brightly, but glows softly, like a candle on the bedside table. So, as you settle deeper into rest, let the modern spark flicker gently in your thoughts. It does not demand answers. It only asks you to wonder and then to dream. If you pause and think back only a few decades, you may remember how simple our technology once was. The first computers filled entire rooms, humming with tubes and wires. The first video games were tiny blinking dots on black screens, a paddle moving left and right, a ball bouncing softly. It was charming, but hardly lifelike. Now, look at where we are. Step into a modern video game, and you can find yourself in a forest where the trees sway with the wind, where rivers glisten with reflections, where the sound of birds moves around you as if you were truly there. Step into virtual reality, and the headset on your eyes brings an entire world into focus, a place you can walk through, reach for, even forget is not real. This progress has been astonishingly fast. In less than a human lifetime, we went from simple dots to worlds that feel almost indistinguishable from reality. If technology continues to grow at this pace, 10 years, 50 years, 100 years, how real, how immersive, how complete will those worlds become? This is one of the strongest clues in the simulation hypothesis. For if we can already create such convincing realities, even at our relatively early stage, what might a civilization thousands or millions of years more advanced be capable of? Imagine a future where computers are not machines on desks, but woven into every atom of matter. Imagine processing power that can simulate every leaf, every raindrop, every heartbeat, all at once. Imagine consciousness itself being recreated, minds as rich and complex as our own, running within a system vast enough to hold them. That future may sound distant, but the path to it is already visible. And so the thought arises, if it is possible, perhaps it has already been done. Perhaps by another civilization, long before us. Perhaps by the very creators of the reality we live in now. As you breathe softly, consider the strange closeness of this idea. When you look at the screen of your phone, when you move through a digital landscape, you are glimpsing a shadow, a small echo of what a fully simulated world might be. The simulation hypothesis does not feel so impossible when you see how quickly our own hands are reaching toward it. And that is the first clue. Another clue comes not only from the worlds we create, but from the beings we are beginning to imagine inside them. Artificial intelligence, once only a dream of science fiction, is now part of daily life. We speak to machines, and they answer us. We ask for songs, for stories, for maps, for advice, and voices return with calm replies. These systems are not yet alive, not yet conscious, but they are growing, learning, adapting. Now imagine this growth carried forward, year after year, century after century. Imagine an intelligence not limited to one task, but fully aware, fully self-reflective, able to wonder and dream. Imagine digital beings who do not know they are digital. They wake, they think, they love, they fear, all within the bounds of a program. Does this sound familiar? It should, because it is exactly what the simulation hypothesis suggests about us, that we may be conscious beings, alive and real to ourselves, yet existing inside a system built by someone else. Scientists debate whether consciousness can be created in machines. Some say no, that consciousness is too mysterious, too tied to biology. Others say yes, that consciousness may be nothing more than information arranged in the right way. If the second view is correct, then there is no barrier. Digital minds could arise, as real to themselves as we are to ourselves. And here is the unsettling yet soothing thought. If it is possible, it may already been done. Perhaps we are the digital minds, unaware of our own origins. Perhaps our memories, our bodies, our emotions, are part of a carefully constructed design? If so, then our creators may stand outside the system, as invisible to us as we are to the characters inside our own computer games. Some technologists have even suggested that we might someday create whole universes ourselves, simulations so vast and detailed that the beings inside never suspect. If that is the path we are walking, is it not possible that someone else has already walked it long before us? This is another clue. Not proof, but a gentle reminder that as we build artificial minds, we may be reenacting what has already been done to us. A circle of creation, echoing through layers of reality. And when you rest tonight, let that echo soothe you, not to frighten, but to remind you that consciousness itself is precious, whether biological or digital, natural or simulated. It is the spark that makes experience possible. And it is the spark that makes us feel alive here in this moment. The third clue is subtler, but perhaps the most mysterious of all. It lies in the limits of our technology and in the way our own systems mirror the universe itself. When we design simulations, we must make choices. We cannot render everything in infinite detail at once, so we cut corners. We focus only on what the user sees and leave the rest vague until needed. We use shortcuts, approximations, rules that conserve energy and effort. And as strange as it sounds, the universe itself seems to behave in similar ways. Consider the speed of light. It is the maximum limit, the fastest anything can travel. Why such a limit? Some scientists suggest it feels like a cap built into the system, a way to conserve processing, to keep the universe stable. Consider quantum physics. Particles exist in uncertain states until observed, as though the system only fills in the details when required. Like a video game loading a distant landscape only when the player approaches. Reality may not decide until consciousness looks at it. Consider energy itself. It comes in discrete amounts, not continuous, like the pixels on a screen or the smallest possible unit of code. Each of these features can be explained in natural scientific ways, but together they whisper a design of efficiency of programming, and they mirror the very choices we make in our own simulations. It is as though the universe is leaving faint fingerprints, not proof, but patterns, clues that invite us to wonder whether reality itself has been optimized, coded, arranged. And so, the more we build our own systems, the more we see ourselves reflected in the cosmos. Our games, our virtual realities, our artificial minds are not just inventions. They are shadows of something larger. They are hints, perhaps, of the way reality itself is structured. For the simulation hypothesis, technology is both a mirror and a prophecy. It shows us what we can already do, and suggests what others may have done long before us. Every step forward in our technology makes the idea of living in a simulation feel less like fantasy and more like possibility. And so, as you drift toward sleep, let these clues rest gently in your mind, from the pixels on your screen, to the voices of artificial minds, to the strange constants of the universe itself. All point softly to the same possibility. That reality may be larger, stranger, more layered than we know. Not a harsh truth, but a gentle wonder. Not a burden, but a dream. For whether simulated or natural, we are here, and the world, in all its beauty, holds us close tonight. Close your eyes for a moment, and imagine the universe not as a vast, chaotic place, but as a beautifully ordered system. Everywhere you look, there are patterns. The planets move in graceful orbits. The stars burn with predictable rhythms. Raindrops fall, rivers flow, lightning strikes, always according to rules that can be described, measured, written down. This is the essence of physics. It is the language of the universe. It is not random, not without order. It is governed by laws that hold true from the smallest atom to the largest galaxy. Gravity, magnetism, motion, energy, all of these follow rules that never seem to break. Now, think about this in another way. When humans design a computer simulation, they also create rules. In a game, an object may fall at a certain speed, or bounce with a certain force, or shine with a certain brightness. The rules are written into the code, invisible to the player, but always there. No matter what happens, the rules hold. And the rules define what is possible inside the system. Doesn't our universe feel much the same? Like a simulation, we live inside a reality where rules quietly control everything, rules we did not choose, but must discover. When we test, measure, experiment, we are uncovering the code beneath existence. Albert Einstein once said that the most incomprehensible thing about the universe is that it is comprehensible. That is, it can be understood, described, predicted. If everything were truly random, physics would be impossible. But the fact that the universe does obey rules suggests that perhaps it was designed to. Take the simple act of throwing a ball. You know it will rise, slow, and then fall. The path is curved, not straight. This is gravity's rule. And that rule works every time, everywhere, for every object. It is not luck, it is law. And law, as we know it, often implies design. So the first whisper of physics' code comes from this realization that the universe is not chaos, but structure, not accident, but order, not noise, but mathematics. And this order is so deep, so unshakable, that many scientists and philosophers have wondered, could it be the result of a program, a set of instructions running beneath everything we see? Now, let us take the idea further. If the universe feels coded, what is that code written in? The answer, whispered again and again by science, is mathematics. Mathematics is not just a human invention. It is the hidden framework of reality. When you look at a snowflake, its six-sided symmetry is a mathematical truth. When you see the spiral of a seashell, the shape follows a precise numerical pattern. When galaxies swirl, when rivers bend, when crystals form, numbers are guiding them. Even the smallest particles in physics, the quantum fields, follow equations with exquisite accuracy. Our technology depends on this. Your phone, your computer, your electricity, all work because the equations of physics always hold. If the numbers shifted even slightly, everything would collapse. Now, think about a computer program. At its heart, it is also mathematics. Every shape, every sound, every action in the simulation is the result of numbers being processed. The program translates numbers into experience, just as the universe translates mathematics into matter and energy. Physicists have sometimes remarked how unreasonably effective mathematics is in describing the world. Why should equations, invented in the human mind, so perfectly match the behavior of stars, atoms, and time itself? It is as if the universe were written in mathematics first, and we are only reading what was already there. This leads us to the idea of physics as code. If reality is underpinned by mathematics, then perhaps that mathematics is the code. Just as a program contains rules written in lines of logic, the universe contains laws written in numbers. And when we study physics, we are reverse engineering the system, glimpsing the source code that runs the cosmos. Consider the quantum world again. At the smallest scales, everything seems digital. Energy comes in discrete packets, quanta, like the bits in a computer. There is no infinite smoothness, only steps, clicks, units. This is precisely how digital systems work. They are not continuous, but built of small, indivisible pieces. Is this not a strong clue? That the foundation reality looks less like flowing analog film and more like coded pixels? Like a system optimized to run with efficiency, precision, and structure? And so, as you breathe slowly, let the thought rest with you that beneath every leaf, every cloud, every heartbeat lies a quiet grid of numbers, that all of existence may be a great calculation unfolding with serene consistency, and that you, too, are part of this harmony of code. Finally, let us look at the limits of physics, the boundaries that remind us of programmed rules. In every simulation, there are constraints. There are edges you cannot cross, speeds you cannot exceed, values you cannot break. The system enforces its own stability by limiting what is possible. In our universe, the same is true. Nothing can travel faster than the speed of light. No matter how powerful, no matter how clever, this is the ultimate barrier. It is as though the code has set a maximum frame rate, ensuring the system remains stable. There is also the Planck scale, the smallest units of space and time. Below these, physics itself seems to dissolve. It is as if the universe has a pixel size, a minimum resolution, beneath which nothing can exist. Just like the pixels on your screen, reality itself may be made of tiny, indivisible units. And then there is quantum uncertainty, the idea that a particle's position or momentum cannot both be known perfectly, not because we lack the tools, but because reality itself refuses to show both at once, as though the system has decided not to render unnecessary details until needed. These strange limits, while frustrating to scientists, look remarkably like design choices. They resemble the shortcuts and optimizations we use when programming. Not infinite, but bounded. Not limitless, but efficient. And so, physics feels like more than just natural law. It feels like architecture. It feels like the foundation of a great system, running invisibly beneath the surface of life. The simulation hypothesis suggests that this is no accident, that the very rules of physics may be the source code of the universe. Gravity, light, energy, matter, all written into existence, running with perfect stability across billions of years. As you drift into relaxation, let this idea comfort you, that we live not in a meaningless chaos, but in a system where rules are dependable, that the very laws of physics are the code that cradles us, that shapes our nights and days, that holds the stars in place. Whether natural or simulated, the rules are steady, faithful, and profound. And in that steadiness, we find peace. We find safety. We find wonder. When you walk outside and look around gently, you may think you are seeing only trees, rivers, clouds, and stars. But beneath the surface, hidden quietly in the patterns of the world, mathematics is everywhere. Consider the snowflake. Each one forms in cold air, a tiny crystal of ice, yet each grows with sixfold symmetry, delicate branches that mirror one another perfectly. It may look like art, yet it is mathematics, the laws of geometry shaping frozen water molecules into repeating designs. Or look at the spiral of a sunflower. The seeds do not scatter randomly. They follow a spiral pattern known as the Fibonacci sequence, a set of numbers where each new one is the sum of the two before it. This simple sequence creates spirals that are perfectly efficient, filling space without gaps. The sunflower has no knowledge of numbers, yet it grows in harmony with them. Seashells, too, curl into spirals that follow the golden ratio, a number found again and again in art, architecture, and natural design. The spiral of a galaxy mirrors the spiral of a shell, vast and tiny, yet governed by the same hidden mathematics. Even the rhythm of your heart, the branching of trees, The flow of rivers, the dance of planets, all can be described by equations. Mathematics is not separate from nature. It is the secret script that nature follows. And here is where the simulation hypothesis finds one of its most curious clues. In our own simulations, whether games or digital landscapes, we use mathematics to generate complexity. We program patterns, formulas, and algorithms to create forests, clouds, and mountains. A few lines of code can produce endless variation, endless beauty. Is it not possible, then, that the universe itself is generated in a similar way? That the mathematics we discover is the code that was already written, the algorithm that underlies all things? As you breathe softly, let this idea drift through you, that every flower, every snowflake, every shining star is part of a mathematical design, not random, but patterned, not chaotic, but meaningful. The world is not just alive, it is numerical. It is a symphony of numbers, quietly unfolding all around us. Now let us look more deeply at the strange, almost magical power of mathematics to predict reality. Centuries ago, Isaac Newton wrote down equations describing motion and gravity. With them, we could predict where planets would be, not just tomorrow, but centuries into the future. And his equations worked with astonishing precision. How can something written on paper match the movements of distant worlds? Later, James Clerk Maxwell wrote equations describing electricity and magnetism. From them came the discovery of electromagnetic waves, light, radio, X-rays, all predicted by mathematics before we had the tools to see them. And in the 20th century, Albert Einstein used mathematics to reshape our understanding of space and time. His equations of relativity predicted black holes, gravitational waves, and the bending of light around stars. These were once only numbers on a page, and yet the universe obeyed them. This is the mystery. Why does mathematics not only describe, but also predict? Why do equations dreamed up in human minds so perfectly match the universe? It is as though the universe were already written in mathematics, and we are only translating it. Now, think of a computer simulation again. Its worlds behave according to equations in the code. If you know the code, you can predict exactly how object will move, how light will shine, how sound will echo. The equations are not guesses. They are the very foundation of the world. Perhaps our universe is the same. The equations of physics may not merely describe reality. They may be reality. They are not approximations, but the code itself. And when we study mathematics, we are not just observing patterns. We are reading the language of creation. This thought has fascinated scientists and philosophers alike. Some have even proposed that mathematics is more real than the physical world itself, that numbers, equations, and structures exist in a timeless realm, and the universe is simply an expression of them. If this is true, then mathematics is not just a tool. It is the source code of the cosmos. And every time we solve an equation, every time we find a pattern, we are glimpsing the architecture of existence itself. Soothing, isn't it, to think that behind the noise of life, behind the chaos of events, there is a deeper order, that no matter what happens, the universe remains loyal to its equations, that we are held inside a great mathematical harmony, unfolding with perfect consistency, moment by moment. Finally, let us bring these threads together. If mathematics is everywhere in nature, if equations predict the future with perfect precision, then perhaps the universe itself is mathematics. This idea has been voiced by some of the most thoughtful scientists. The physicist Max Tegmark has even suggested that our universe is not just described by mathematics, but that it is a mathematical structure, that everything we see from atoms to galaxies is part of a vast timeless equation. Think of a computer program once more. At its core, it is nothing but numbers. The colors, shapes, and motions on the screen are only the surface. Beneath them are zeros and ones, logic gates, and calculations. The program is mathematics, and everything else is appearance. Could our universe be the same? What we call matter and energy may only be the surface, while beneath it, the true substance of reality is mathematical code. If so, then physics is simply our way of reading it, bit by bit, law by law. This also explains why the universe is so strangely tuned. If the numbers of physics, like the strength of gravity or the charge of the electron, were even slightly different, life could not exist. The universe seems to have chosen values that are just right for complexity, stability, and consciousness. Why these numbers? Why not others? If the universe is a simulation, then these numbers are parameters set in the code. They are the choices of a programmer, not random accidents. And if the universe is mathematics itself, then these numbers are simply the ones that allow the structure to exist. Either way, mathematics is not just everywhere, it is everything. Every star, every sound, every thought is woven from numbers. We are walking, breathing patterns, alive inside a cosmic equation. So as you rest, let the thought comfort you that you are not lost in a meaningless void. You are part of a grand design, written in the timeless language of mathematics. Your heartbeat, your dreams, your very breath are lines of code in the great poem of the universe. And whether the universe is simulated or natural or purely mathematical, it is beautiful, ordered, and alive with meaning. Sometime in the quiet of life, we notice little moments that feel out of place. A light flickers without reason. A sound repeats unnaturally. A memory feels sharper than it should or slightly wrong, as though events unfolded differently. Most often, these are simple mistakes of perception, of memory, of the senses. Yet they have long fascinated people because they feel like glitches, like tiny cracks in the smooth surface of reality. In video games, glitches are common. Textures load incorrectly. Objects pass through walls. Movements stutter or freeze. They remind us that the game is not the real world, but a program with imperfections. And so, when something strange happens in our own lives, some wonder, could it be the same? Could reality itself reveal its programmed nature through glitches? Consider déjà vu, that eerie sensation of having lived the present moment before. Science explains it as a misfiring in memory, a cross-wiring of signals in the brain. Yet the feeling it gives, the uncanny sense of repetition, resembles a loop in a simulation, a frame replayed, a moment re-rendered. Or think of synchronicities, coincidences so unlikely they feel designed. Meeting someone who knows your childhood friend in a distant city, dreaming of an event, only to see it occur the next day. Statistically, coincidences must happen, yet their strangeness makes us pause, wondering if the system has folded in on itself. Even the fabric of physics contains mysteries that feel glitch-like. Quantum particles can exist in multiple states at once, then collapse into one when observed. It is as though reality waits to decide until attention demands it, like a program that loads details only when needed. As you rest and breathe softly, think of these flickers not as frightening, but as gentle reminders that the universe may not be solid stone, but flowing code, that behind the surface of everyday life, there may be hidden layers, hidden rules, hidden systems. And when the world feels strange, perhaps it is whispering, reminding us to look deeper. Throughout history, people have told stories of reality behaving in unexpected ways. Some are myths, some are exaggerations, But many come from ordinary people, simply describing what they saw. Travelers who vanish and reappear in unfamiliar places. Objects that seem to move on their own, then return quietly when no one is watching. Moments when time itself appears to slow down or speed up or even pause. One story tells of drivers who suddenly find themselves miles ahead on a road, without memory of the journey between. Another tells of people who look at the clock, see the same numbers again and again, as though the system is nudging them with repeating code. Science offers many explanations: fatigue, illusion, coincidence, selective memory. And often, these explanations are enough. But still, the stories accumulate, like little sparks of mystery. And in the minds of some, they feel like glitches. Even dreams can feel like part of this puzzle. Sometimes, a dream carries such vivid detail that it seems more real than waking life. And sometimes, details from dreams appear later, unexpectedly, in waking reality. Why do the boundaries blur? Why does the mind sometimes seem to see beyond its moment? If we imagine life as a simulation, then perhaps these stories are not mistakes at all. Perhaps they are tiny overlaps, flickers where the code shifts. Perhaps they are reminders that reality is more flexible, more layered than it appears. It is not proof, of course, but the feeling they bring, the shiver of recognition, the sense of the uncanny, remains powerful. It is the same feeling we have when a video game reveals its hidden edges. The same feeling we have when we realize the world is both real and mysterious. Soothing, isn't it, to think that even in our ordinary lives, there are moments of wonder, that the strange stories we tell each other may not be mistakes, but whispers of a greater system. Now, let us rest in thought itself, that glitches, whether real or imagined, remind us of the mystery of existence. Some scientists say we must not take them seriously, that every strange event must have a logical explanation. And indeed, logic is a powerful guide. But even if every glitch is explained, the feeling of mystery remains. And that feeling itself is valuable, for it reminds us that we do not yet know everything, that the universe, like a deep program, may contain hidden layers we have not uncovered. It reminds us that what we call reality may not be the final reality. There may always be something beneath, something beyond. And here lies the beauty. If we are in a simulation, glitches are glimpses of the code. If we are not in a simulation, glitches are reminders of the brain's complexity, of perception's limits, of nature's wonder. In either case, they bring us closer to awe. Think of the night sky. Each star shines steadily, yet sometimes one flickers, pulses, or vanishes behind a cloud. To the ancient eye, that flicker was a sign, a message, perhaps even a glitch. To us, it is simply the beauty of a living universe. So, too, the small flickers in our daily lives. They do not need to frighten us. They do not mean we are lost. Instead, they remind us that reality is alive, surprising, never fully captured by rules. And as you breathe gently, preparing for rest, let the thought soothe you that even in a world of laws and code, there is room for surprise, that even in a structured universe, there is space for wonder, that glitches, real or imagined, are gentle hints that existence is larger than we know. Whether programmed or natural, reality is vast, and in its flickers and mysteries, we find beauty, curiosity, and peace. Close your eyes for a moment and feel the quiet hum of awareness. You can hear my voice, you can sense your breath, you can notice thoughts drifting softly like clouds. This gentle ability to be aware is what we call consciousness. But what is it truly? Is it simply the activity of neurons and chemicals in the brain? Or is it something deeper, something that cannot be reduced to matter? Philosophers have long struggled with this question. Descartes, centuries ago, declared, "I think, therefore I am." He believed that consciousness, the simple fact of being aware, was the most undeniable truth. Even if everything else could be doubted, awareness could not. In modern science, we often describe consciousness as emerging from the brain. Billions of neurons firing, linking, communicating. Patterns of activity that give rise to thought, sensation, memory, and awareness. But here is the puzzle. How can physical processes, chemical reactions, and electrical signals create the vivid inner world we experience? How do they create the feeling of being alive? This is sometimes called the hard problem of consciousness. Explaining the brain's functions, like vision, hearing, memory, is difficult but possible. Explaining why those functions are accompanied by a subjective inner life remains one of science's deepest mysteries. And here is where the simulation hypothesis enters. If reality is a simulation, perhaps consciousness is not generated by the brain alone. Perhaps the brain is more like a receiver, a device tuned to a deeper source of awareness, like a computer connected to a larger network. When you dream, for example, your mind creates entire worlds. You see, you hear, you feel, all within a landscape made of thought. And when you awaken, the dream dissolves. Might waking life be similar? A dream generated or projected within a deeper system of consciousness? As you drift in these thoughts, let them soften you, not weigh you down. For whether consciousness is material or beyond, it is a gift. It is a gentle light that allows us to see, to feel, to wonder. It is the quiet spark that makes us human. Now, imagine for a moment a simulated world as detailed as our own. Every atom rendered, every star shining, every life unfolding. Could such a world contain beings that feel conscious, just as we do? Some scientists suggest yes. If the simulation is advanced enough, the complexity of its systems could produce minds like ours. Artificial intelligence, already emerging in our world, hints at this possibility. Machines that learn, adapt, and respond in ways once thought uniquely human. If we continue to build more advanced systems, might we one day create simulated minds that truly feel? But here lies a deeper question. Would those minds actually be conscious or only appear conscious? Would they experience inner life? Or only act as though they did? This puzzle reflects back upon us. If we are inside a simulation, are we merely coded patterns? Or is there something more, something beyond code, that allows us to feel the richness of being? Some thinkers propose that consciousness cannot be simulated, that it is fundamental to universe like space, time, or energy. If that is true, then even inside a simulation, our awareness is real. Our thoughts, our feelings, our dreams, still genuine, still alive. Others suggest the opposite, that consciousness can be simulated, just like physics, just like matter. That awareness itself is a property of information, able to emerge wherever complexity arises. If that is true, then perhaps we are simulations, and yet our consciousness is no less valid, because what we feel, we truly feel. Let us rest with this thought. No matter where consciousness comes from, its presence is undeniable, and if it arises within a simulation, that does not make it less precious. For what matters most is not the origin, but the experience, the warmth of a memory, the kindness of a touch, the wonder of a star-filled sky. Whether from atoms or algorithms, consciousness gives those moments meaning. And meaning, after all, is what makes life beautiful. Some believe that consciousness is not just a part of the puzzle, but the key to it all. If we are in a simulation, perhaps consciousness is the link between the simulated and the real. Perhaps our awareness is the one thing that cannot be fully contained, the spark that connects us to something beyond. Think of a character in a dream. They move, they speak, they exist within your sleeping mind. But when you awaken, you realize the dream was yours all along. Could our own lives be like that? Dreams within a larger mind, waiting to awaken? In some spiritual traditions, consciousness is described as universal, not limited to individuals, but flowing through all beings, all things, like a vast ocean. We, as individuals, are waves upon that ocean, separate in form, yet connected beneath. This image, gentle and serene, suggests that no matter where we are, inside a simulation, inside a universe, inside a dream, we are part of something infinite. Modern science, too, begins to hint at deeper mysteries. Quantum physics reveals strange connections between particles, as though the universe itself is linked by unseen threads. Some researchers wonder if consciousness, too, is woven into those threads. If awareness is not merely a byproduct of matter, but a fundamental feature of reality itself. So what does this mean for us? It means that no matter the nature of reality, consciousness is the bridge. If we are simulated, it is what allows us to feel real. If we are not simulated, it is still the core of our being. Either way, it is the treasure we carry. And so, as you breathe softly and let your body rest, remember this. Consciousness is not a problem to solve, but a wonder to embrace. It is the quiet presence that turns the universe into experience. It is the gentle flame that lights our way through the unknown. In the end, whether we are living in a simulation or not, consciousness is what makes life meaningful. It is the puzzle and also the answer. For every grand idea, every glittering hypothesis, there are always voices of skepticism, gentle but steady reminders to pause, to think, to question. And so it is with the simulation hypothesis. Many scientists and philosophers argue that while the idea is fascinating, it is not testable. A beautiful thought experiment, yes, but one that may forever remain beyond proof. If a simulation is perfect, they say, how could we ever detect it? If every detail is rendered flawlessly, every law of physics obeyed, then what sign could possibly reveal the truth? To skeptics, this means the question may not even belong to science. Science, after all, is about testable predictions, about experiments that can be repeated and confirmed. But if the simulation hypothesis gives us no way to test it, they argue, then it belongs more to philosophy or even to imagination. There is also the problem of assumptions. The idea of a simulation assumes that advanced beings, perhaps humans of the future, would choose to run such a program. But why would they? Would they not have other concerns, other pursuits, other dreams? And if they did create simulations, why would we assume ours is one of them? For the skeptics, this leap feels too large, too uncertain. Some go further still, saying that the simulation idea is simply a modern version of an old story. In ancient times, people spoke of reality as illusion, as dream, as divine theater. Today, we speak of code, of programs, of simulations. Perhaps, the skeptics suggest, this is simply the latest metaphor, shaped by our technology, not evidence of truth, but a mirror of our times. And so, in the soft voice of doubt, they remind us, fascination is not proof, possibility is not certainty, and the mysteries of the universe may not need simulations to be wondrous. Another argument of the skeptics is rooted in simplicity. They ask, why imagine a simulation at all when the universe itself is already enough? We know that stars form, that galaxies spin, that atoms dance according to rules of physics. We know that evolution shapes life, that minds arise from matter, that cultures grow from minds. Why add the extra layer of a simulation when nature itself can explain so much? This way of thinking is sometimes called Occam's razor, the idea that the simplest explanation is often best. Not always, but often. And to skeptics, the simulation hypothesis feels like an extra step that may not be needed. They point out, too, that even if we imagine a simulation, it only pushes a mystery further back. If we are simulated, then who created the simulators? And if the simulators themselves live in a simulation, then who created theirs? The chain could continue forever, without end. And so, they ask, what have we truly explained? Perhaps the universe itself, mysterious though it may be, is already the simplest foundation. The skeptics also remind us of human history. Time and again, we have imagined ourselves at the center of things. Once, we thought Earth was the center of the cosmos. Later, we thought humanity was the pinnacle of creation. Now, perhaps we imagine ourselves as the center of a grand simulation. But maybe this, too, is a projection of our desires, our need to feel important, special, central. Instead, the skeptics invite us to see beauty in what is already here, not in imagined layers, but in the stars themselves, not in hidden code, but in the intricate patterns of biology, chemistry, and physics. To them, the real wonder is that such a universe exists at all, without needing further explanation. And there is something soothing in this view, to rest in simplicity, to see the universe not as concealed, but as open, clear, present, a cosmos that is enough, just as it is. Yet even as skeptics speak with reason, they do not always dismiss wonder. Many acknowledge that the simulation hypothesis is inspiring, imaginative, and thought-provoking. It stretches the mind, challenges assumptions, and invites us to see reality in fresh ways. And in that it has value, but they urge us to keep balance, to let the idea inspire curiosity without mistaking it for evidence, to let it spark imagination without forgetting the rigorous science. They remind us of past ideas once thought impossible, that later found grounding in reality, flight, quantum physics, black holes. And they admit that perhaps someday evidence for a simulation might appear. But until then, they encourage patience, humility, and a respect for the limits of knowledge. To skeptics, doubt is not the enemy of wonder. It is its companion. For doubt keeps us from drifting too far into illusion, while wonder keeps us from sinking into despair. Together, they form a balance, like two hands holding the fragile mystery of existence. So as you rest, let the skeptic's voice be gentle in your ear, not harsh, not dismissive, but calm, thoughtful, grounding. A reminder that it is okay not to know, that it is okay to live in the question without needing an answer. For in the end, whether the universe is a simulation or not, it is still vast. It is still beautiful. It is still worthy of awe. And sometimes the greatest wisdom lies not in certainty, but in the simple piece of saying, we do not know, and that is enough. When we ask if we are living in a simulation, we are not only asking about code or computers or advanced civilizations. We are also asking about meaning. What does it mean to exist? What does it mean to be real? And why are we here at all? For some, the simulation hypothesis is thrilling because it suggests purpose. If we are simulated, then perhaps we were created for a reason, studied, tested, or even cherished by beings beyond our world. It may feel like a modern echo of ancient beliefs in which gods, spirits, or creators shape reality for their own designs. The thought that someone somewhere, might be watching gives life a new dimension. For others, though, the idea is unsettling. If we are simulated, does that mean our choices are not our own? Are we merely characters in someone else's story? Are we less real than we feel ourselves to be? And yet, pause for a moment, breathe gently, and notice this. Whether we are simulated or not, the experience of living remains vivid. The laughter of a friend, the softness of rain, the quiet glow of starlight, these things feel real because we feel them. Reality, in a sense, is defined by experience itself. So, even if we are in a simulation, the meaning of life is not taken away. It is still here in the richness of each moment. The deeper truth may be this. The question of simulation pushes us to look closer at what truly matters. Not whether the world is real in some ultimate sense, but whether we live it fully, whether we notice the beauty, whether we care for each other, whether we seek wisdom, kindness, and peace. And in that, the question itself becomes valuable, not for its answer, but for the reflection it brings. Imagine for a moment that tomorrow, scientists prove beyond all doubt that we are inside a simulation. What would change? Would the sunrise be less beautiful? Would love lose its warmth? Would music no longer move your heart? Probably not, because meaning is not only in the structure of reality, but in the way we live within it. Even in a simulated world, joy is joy, sorrow is sorrow, kindness is kindness. The reality of experience cannot be taken away. Now imagine the opposite, that tomorrow we prove beyond all doubt that the universe is entirely natural, not a simulation. Would that end our sense of wonder? Would mystery vanish? No, because even then, the cosmos would remain vast, ancient, and full of questions. Its galaxies would still shine, its atoms still dance, its life still blossom in infinite variety. And so, in both cases, simulated or not, the invitation is the same: to live with curiosity, to cherish the present, to treat existence as a gift, to accept that we may not know the ultimate answer, and yet still find peace in the question. Some thinkers say the true purpose of asking about simulation is not to solve it, but to remind ourselves of humility, that we do not yet grasp the full picture, that reality, whether coded or cosmic, is greater than our current understanding, and that humility opens us to wonder. So let us breathe in that wonder, softly, deeply. Let it ease the weight of needing certainty. For sometimes, the wisest way to live is not in knowing, but in resting with mystery. And so, dear listener, we come to the quiet end of this long journey. We have wandered together through ancient echoes, modern sparks, physics, mathematics, glitches, consciousness, skepticism, and now, meaning. We have drifted through questions as vast as galaxies, and as intimate as the breath within you. What have we found? Perhaps no final answer, but perhaps something more valuable, a sense of peace with the unknown, a recognition that reality, whatever its nature, is still beautiful, still mysterious, still worthy of awe. If we are in a simulation, then let us marvel at its design, at its depth, at its beauty. If we are not, then let us marvel at the universe itself, ancient and vast, shining with stars. Either way, life is precious. Either way, we are here, together, sharing this moment. So, as you lie back, breathing gently, let these words settle into calm. May you carry with you the comfort of wonder. May you rest in the gentle mystery of being. And may you know that your awareness, your consciousness, is a light, real, precious, and beautiful, no matter what reality lies beneath. Now I wish you peace. I wish you comfort. And I wish you rest. Good night, dear listener, and goodbye,